Okay, so here one by one I have taken each and every chapter. Today, let's discuss all the theorems from circles. Okay, here only will be like quick. I'll just give you a review of all the theorems so that you are done with all the theorems from circles. Okay,
Okay.
okay, just a second. And in case if you have recently practiced all the theorems, then you can let me know what else you want to do over here. Do you want to do anything else? Any other chapter? Revision?
No.
Okay, so let's continue with circles. One day circle will be completing all the theorems, one day quadrilateral, and we are done. Okay, these two are the like theorem based chapter. So many theorems are there. So if we will revise like you can if we will discuss it over here, a brief discussion, then it will help you okay in your preparation. So yeah, just a second. You can already see the screen, right?
Yes, ma'am.
Okay. So everyone join. Let's wait for a few more minutes, okay? So that everyone can join and we can start then. Okay. Okay, let's start the discussion. Okay. You all can see the first theorem, the perpendicular from the center, okay, of a circle. Just let me minimize it a bit. Yes. Can you see the screen, everyone? Is it readable?
Yes, ma'am.
Okay.
Yes, ma'am.
Let's continue. So the first theorem is the perpendicular from the center of a circle to a chord. See the theorems over here in class 9. It's really important if you are thinking anyone, okay, if you are thinking that in your school they don't ask so many theorems, okay, it's not that important. So maybe it's not that important for your exam, but be careful after exam. Please sit with it. If your teachers have said that they are not going to give so many theorems, and if you are just focusing on the questions, okay, please sit with the theorem after the exam, because in class 10 we just say that there was a theorem, okay, where we are just dropping a perpendicular on the chord and our chord is getting bisected. This is how, okay, in between so many concepts we use this concept on daily basis. Okay, so you should be comfortable and okay familiar with this theorem. So let's continue. Next, the first theorem says that the perpendicular from the center, if we are dropping a perpendicular from the center of the circle, we are dropping the perpendicular from the center of the circle, okay, to a chord. On the chord we are dropping any random in a circle, any random chord we are having, any chord, maybe like this, or maybe like this, or maybe like this. Okay, and from the center we are dropping the perpendicular on the chord. So from center O we are dropping the perpendicular on the chord. From center O we are dropping the perpendicular on the chord. From center O we are dropping the perpendicular on the chord. Then we have to show that it is going to bisect the chord. Our chord is getting bisected. This theorem is really simple. You just have to understand that you have to show that if you are having a chord AB, okay, and on that AB, if you are dropping a perpendicular from the center O, suppose OP is the perpendicular which you have dropped on the chord AB, then you have to show over here that AP is equals to BP. Okay, so at first we will write that what is given over here and what we are supposed to prove over here. So as you can see, the first two, let me highlight it. The first step over here is this one. Okay, we are supposed to prove that AP is equals to BP, and we are already having in hand that OP is perpendicular to AP, right?
Yes,
Right.
ma'am.
Okay, now in what we'll do, we will just join O with A, O with B, and we will be taking triangle on the left OAP and triangle on the right OBP. And in our mind, it must be really clear that what we are supposed to do. Anyway, if we can prove the left triangle and the right triangle, these two are congruent, then we can say that, of course, this AP and BP will be same by CPCT, right?
Yes, ma'am.
Okay, so that's what we are trying to do. We have taken triangle OAP and we have taken triangle OBP, and we are trying to prove them congruent. At first, we can say that OA and OB are same because these two are nothing but just the radius of the same circle, right?
Yes, ma'am.
Okay, OA and OB are same. Then OP is the common side. Okay, and angle P over here, angle P over there, both are 90 degrees, and very easily you will be able to prove them congruent. Once you are done with proving them congruent, then you can say now AP and BP will be same by CPCT, and we are done. Clear to everyone?
Yes, ma'am.
Okay, so the first thing, what is given, what we are supposed to prove, if you identified that really well, then proving will not be difficult. Okay, then we are having the converse of the same theorem. The converse of the same theorem says that the line joining the center of a circle to midpoint of the chord. Okay, the converse says that this time, पिछली बार हम क्या कर रहे थे, हम परपेंडिकुलर ड्रॉप कर रहे थे एक रैंडम कोई भी किसी भी एक कॉर्ड पे सर्कल inside the circle you can draw infinitely many chord. Okay, and any random chord you are taking, and on that chord you are dropping the perpendicular, and then we were proving that that perpendicular is bisecting our chord. Now this converse part says that if we are having a circle, then the line joining the center of a circle to the midpoint of the chord, line joining the center of the circle to the midpoint of the chord. Okay, this time we are joining the center with the midpoint of the chord. Then the line which is joining the center and the midpoint, this line is perpendicular to the chord. That's what we have to prove. Getting it?
Yes, ma'am.
Okay, so this time what we are doing, already we know M is the midpoint. Okay, the chord is getting bisected. AM and BM are same, we know that. But when we are joining this midpoint with the center, we realize that this is perpendicular. That's what we have to prove. Okay, this is perpendicular. OM automatically came as a 9, just making 90 degree with AB. That's what we have to prove. Okay, so how we'll be proving this one? Again, the triangle on the left and the triangle on the right. Okay, here you have to show them these two are congruent, and let me tell you, very easily you will be able to prove that this triangle OAP and OBP are, these two are congruent. Okay, again you can take this OA and OB are equal. Again, you can say that OA and OB are equal. Why? Because these two are radius of the same circle. Okay. Now you can say OP is the common side. And then you can say that AP and BP are equal. Okay. AP and BP are equal because that is given in the question, that already we know the midpoint. P is the midpoint over here. So AP and BP are equal. Then by side congruency, can you see this two triangles are congruent with each other? Yes or no?
Yes, sir.
And once these two triangles are congruent with each other, okay, now you can say that angle over here, and the angle over here, these two are equal. We don't know it is 90 degree or what, but by congruency we can say that angle over here and angle over there are equal. Yes or no?
Yes, sir.
Okay. And if these two angles are equal, if this is x, this will also be x by CPCT, of course. Okay. Then x plus x added together is making linear pair as well. We are realizing. Are you realizing?
Yes, sir.
Okay. And from here, can you see very like it's really simple to prove that yes, x is nothing but 90 degree.
Yes, sir.
Clear this two theorem. Even if after this class you are not revising, is still, if we will take a test or this theorem will come in exam, you will be able to do it, right?
Yes, sir.
Okay. Next, equal chord of a circle are equidistant from the center. First, you need to understand what is given, what we are supposed to prove. Equal chord. Okay. Circle we are having in which two chords are there which are equal. Okay. A chord maybe AB is there and a chord maybe PQ is there, and these two are equal. Why? Because it is written in the question that two chords we are having which are already equal. Chord means you must understand. Okay. If anyone is not getting what is chord, chord का मतलब होता है अगर हम सर्कल के ऊपर किसी भी दो पॉइंट को लेके ज्वाइन करें, तो जो हमें लाइन सेगमेंट मिलता है उस लाइन सेगमेंट का एक स्पेसिफिक नेम है, एंड दैट्स द chord. Okay, so equal chord of a circle are equidistant from the center. We have to show that these two chords which are equal in length, okay, these two are having equal distance, maintaining equal distance from the center of the circle. Whenever we are talking about distance of a point from a line, then we are talking about the perpendicular distance. You all know that, right?
Yes, sir.
Okay, whenever we are talking about distance of a point from a line, that means we must be thinking about a perpendicular distance because that is the shortest distance. Okay, so here these two chords are maintaining same distance from the circle. The center of the circle. Okay, that means this distance, if you are taking it as a n, this on, the perpendicular distance, and this distance om, these two are same. Okay, if this is 5 centimeter, this is also 5 centimeter. That's the meaning of that. So very clearly we have written that we know that AB is equals to PQ, and we have to show that OM is equals to ON. Till here, is it clear to all of you?
Yes, sir.
Okay. Now again, we will be drawing a triangles and we will try them proving congruent. Okay. So I'm drawing the figure over here. Now we will join this O with B and this O with Q. And you can see two triangles, right? I'm talking about triangle BOM and triangle NOQ. Can you see that? Or QON?
Yes, sir.
Here we will try proving them congruent. Once we can prove these two are congruent, then automatically OM and ON will be equal by CPCT, right? So let's try proving it. We already understand that OB and OQ, these two are nothing but the radius of the same circle, right? OB is also the radius and OQ is also the radius. Okay. Now what else we can say? We will say that since we know that AB and PQ are equal with each other, already it was given in the theorem that AB and PQ, these two are equal in length. Okay, and now we have dropped the perpendicular from O. Okay, that is ON. So our chord must be getting divided in two equal parts. Yes or no?
Yes, ma'am.
Okay, if we are having a chord, and on that chord we have dropped the perpendicular from the center. That distance we don't know whether it is same as the other one or not, but we have dropped perpendicular, and that is dividing our chord in two equal parts. That is the first theorem, right? Perpendicular on the chord bisect the chord, right? Everyone getting it?
Yes,
Yes, ma'am.
Okay, so we can say that this Qn and Pn must be equal. So you can see here I have written that MB and NQ are equal. Why? Because AB and PQ was equal, and half of AB and half of PQ will also be equal. Is it making sense to all of you? Yes or no? Getting it?
Yes, ma'am.
yes, ma'am.
Okay. Still our purpose is clear. We are trying to prove them congruent. And then automatically we'll be saying OM, ON are same. Okay. One more thing, we are getting 90° here, 90° there. Now let's see which congruency is working. So 90° hypotenuse and one of the side. RHS congruency is working over here. Yes or no?
Yes, ma'am.
And hence we can say that these two triangles are congruent, and by CPCT OM and ON will be equal, right?
Yes,
Okay, so this was the third theorem. Next is the converse of the same theorem. Let's do it. Chord of a circle which are equidistant from the center are equal. Chords of a circle which are equidistant from the center. If you are having two chords, any two chords you are having, which is maintaining same distance from the center. Okay, any two chords you are having, just this chord and that chord. We don't know both chord are same or not. Okay, but we know that the distance of this chord from the center O and the distance of that chord from the center O, this two distances are same. If this is X, this will also be X. That's what is given in the question. Okay, then prove that chords are equal. Getting it? Here it is given that OM is equals to ON. That means the distances are same from O to N, and from O to M the distances are equal this time, and we have to prove that AB is equals to PQ. The chord are same in length. So again we'll be taking the same triangle over here. Okay, you will be able to prove them congruent. You know OM is equals to ON. Okay, you know the radius over here OB and the radius over there OQ same, and what else, 90° here, 90° there. Okay, because distances are same, that means perpendicular distance are same. Okay, so 90° here and 90° there, so angle M over here is equals to angle N over there. Now let's see which congruency criteria is working over here. 90° hypotenuse and one of the side is still RHS, right?
yes, ma'am.
And now we can say that hence MB is equals to NQ. Okay, this much only. MB. and this much only NQ, these two are equal, then the double of this two will also be equal. Why we are saying the total, like this complete AB is the double of MB? Because again the same concept, the first theorem, हमने हमारे कॉर्ड पे एक परपेंडिकुलर ड्रॉप किया है और वहां से हमें ऑलरेडी पता है, ओके, द डिस्टेंसेस आर सेम, हमारे जो कॉर्ड का लेंथ है वो इक्वल है या नहीं है हमें नहीं पता, हमें बस पता है कि डिस्टेंसेस इक्वल है। कौन सा डिस्टेंस? परपेंडिकुलर डिस्टेंस इक्वल है। जैसे ही हमारे कॉर्ड पे परपेंडिकुलर हमने ड्रॉप किया होगा वैसे ही हमारा कॉर्ड दो पार्ट में डिवाइड हो गया होगा, ओके, इतना हमें पता है। अब दोनों कॉर्ड आपस में इक्वल है या नहीं ये हम नहीं जानते, बट लेफ्ट वाले कॉर्ड के ऊपर जैसे ही हमने सेंटर से परपेंडिकुलर ड्रॉप किया हमारा कॉर्ड दो इक्वल पार्ट में बट गया होगा, यस और नो?
Yes, ma'am.
एंड सिमिलरली राइट वाले कॉर्ड पे हमने जस्ट परपेंडिकुलर ड्रॉप किया है। क्यों? परपेंडिकुलर डिस्टेंस जस्ट शो करने के लिए कि दिस डिस्टेंस एंड दिस डिस्टेंस आर सेम, जस्ट हमने डिस्टेंस शो करने के लिए परपेंडिकुलर ड्रॉप किया लेफ्ट में एंड परपेंडिकुलर ड्रॉप किया राइट में। बस वहां से हमें ये पता है कि हमारा कॉर्ड क्या है, दो इक्वल पार्ट में, लेफ्ट वाला कॉर्ड भी डिवाइड हो चुका है, राइट वाला कॉर्ड भी डिवाइड हो चुका है। Okay, still we don't know both are equal with each other or not. That's what we are proving over here. Okay, so by congruency already we have proved that the triangle over here and the triangle over here, these two are congruent. If these two are congruent, okay, then this much length of the chord and this much length of the chord, these two are same. But हमें तो पता है कि ये जो लेंथ है हमारे पास ये हाफ है पूरे लेंथ का, और ये जो लेंथ है हमारे पास ये भी हाफ है पूरे कॉर्ड का, मतलब पूरा का कॉर्ड आपस में इक्वल होगा। इज इट मेकिंग सेंस?
Yes, ma'am.
From here we are saying that AB and PQ are equal. Is it like anyone having any doubt over here? Okay, let's continue. Next, equal chord of a circle subtend equal angle at the center. If two chords you are having, okay, in a circle, if two chords you are having, maybe chord PQ and maybe chord AB, you don't know, wait, you just know that these two chords are same in length. Why? Because equal chord, okay, these two are equal chord, then we have to show that these two are creating same angle at the center. Okay, we have to show that these two chords are creating same angle at the center. I have seen a student is struggling with the concept that how chord creates an angle, how arc creates an angle. So let me make it clear, because these things I have explained so many times to class 10 students as well. So here only it must be clear to each and everyone that if I am saying that there is an arc, if I am saying that there is an arc in the circle which is subtending angle on the circumference of the circle, okay, that means the one of the end point of the arc we will join with any point on, like, let me make it more clear, okay, otherwise you will end up getting confused. अगर मैं बोल रही हूं कि हमारे पास एक आर्क है ए बी, ये आर्क पॉइंट पी पे एंगल क्रिएट कर रहा है, तो चलो देख लेते हैं आर्क कैसे एंगल क्रिएट करता है। आर्क जब भी एंगल क्रिएट करेगा मतलब one end point we will join with point P and another end point we will join with the same point P, and this is the angle created by an arc AB. Is it making sense to all of you?
Yes,
Yes,
ma'am.
ma'am.
ओके, अगर मैंने बोला ये जो सेम आर्क है ये सेंटर पे एंगल क्रिएट कर रहा है, तो सेंटर पे कैसे आर्क एंगल क्रिएट करेगा? फिर से एंड पॉइंट वी विल बी जॉइनिंग विद सेंटर, another end point we will be joining with center, and now we can say that the same arc AB is subtending or creating angle at the center of the circle. Getting it?
Yes, ma'am.
Okay, and the same thing I can also say in this way, that chord AB subtending angle at P. chord AB subtending angle at O. ओके ये दोनों एक ही बात है, आर्क एंगल बना रहा है या कॉर्ड एंगल बना रहा है, एक ही बात है. कभी हम आर्क बोलते हैं, कभी कॉर्ड बोलते हैं, बट दिस टू आर सेम थिंग. गॉट इट?
Yes, ma'am.
Okay, now let's continue with this theorem. So here the theorem says that if in a circle, if we are having two chords, any two chord, this chord, maybe this chord, okay, but both are equal. So if you are saying one of the chord is PQ and another chord is MN, so PQ and MN, okay, these two are equal in length, then we have to prove that this angle created by PQ at the center is same as angle created by MN at the center. Are you getting it? Equal chord of a circle subtend equal angle at the center. Yes or no?
Yes,
Yes.
ma'am.
Okay, and still we will be trying proving this two congruent. That's why when I started the discussion of triangle chapter, I said that this chapter is really important and you need to understand it really well, because after triangle, in quadrilateral, everywhere just congruency, congruency, congruency. Then in circle, everywhere you can see till now what we are doing, just proving congruent, and that too really simple triangles and all, right?
Yes, ma'am.
ओके सो वी विल बी टेकिंग ट्रायंगल पीओक्यू, वी विल बी टेकिंग ट्रायंगल एमओएन, और बहुत सिंपल है इन दोनों ट्रायंगल को कॉन्ग्रुएंट प्रूव करना. देखो बहुत सारी चीजें हैं जो आपस में इक्वल है. पीक्यू एंड एमएन तो ऑलरेडी इक्वल है, ऐसा क्वेश्चन में लिखा हुआ था दैट इक्वल कॉर्ड. ओके, अब यहाँ पे हम देख पा रहे ओपी, ये जो ओपी है, ये जो ओक्यू है, ये जो ओ एम है एंड ये जो ओ एन है, ये सारे ही रेडियस ऑफ द सेम सर्कल है, राइट?
Yes, ma'am.
हमें जैसे मन वैसे हम कंपेयर कर सकते हैं. हम बोल सकते हैं कि OP इज सेम एज OM एंड OQ इज सेम एज ON. अगर हमने OP को ON से कंपेयर कर दिया तो क्या कुछ डिफरेंस आ जाएगा? बिल्कुल नहीं. ओके, nothing will change, still your angle O will be sitting in the middle over here and O will be sitting in the middle over here, and you can at last say angle O over here, angle O over here will be same by CPCT. Getting it?
Yes, ma'am.
ओके बस हमें इन दोनों ट्रायंगल को कॉन्ग्रुएंट प्रूव करना है. कैसे भी हम कंपेयर करें, मैंने यहाँ पे लिख के दिखाया दैट ओपी, ओक्यू, ओएम, ओएन ये सारे ही बस रेडियस है सेम सर्कल के. तो जैसे मन वैसे कंपेयर कर लो, यू विल बी गेटिंग द कॉन्ग्रुएंसी प्रॉपर्ली, एंड एट लास्ट यू हैव टू शो दैट एंगल ओ ओवर हियर, एंगल ओ ओवर हियर आर इक्वल. ओके, विच यू विल बी एबल टू डू इट. क्लियर?
Yes, ma'am.
Next, the converse of the same theorem. If the angle subtended by two chord of a circle at the center are equal, अगर angle same है, दो कोई भी दो रैंडम chord है हमारे पास, ओके सर्कल के अंदर बहुत सारे chords हम ड्रॉ कर सकते हैं. हमारे पास कोई दो chord है बट दोनों chord सेंटर पे सेम एंगल क्रिएट कर रहा है, तो हमें यहाँ पे ये शो करना है कि ये दोनों chord सेम लेंथ के हैं. फिर से हम इन दोनों को कॉन्ग्रुएंट प्रूव करेंगे, जो कि बहुत सिंपल होगा. एंड बाय साइड एंगल साइड कॉन्ग्रुएंसी यू कैन सी क्लियरली, यू विल बी एबल टू से दैट या दिस टू ट्रायंगल आर कॉन्ग्रुएंट, राइट?
Yes, ma'am.
एंड अगर ये दोनों ट्रायंगल कॉन्ग्रुएंट है तो ऑफ कोर्स बाय सीपीसीटी एमएन एंड एसटी विल बी सेम, राइट?
Yes, ma'am.
ओके सो अब तक हमने जितने भी थ्योरम डिस्कस किए हैं, ये नंबर्स अगर हम काउंट करने बैठे तो हो सकता है नंबर्स 5, 6, 7, 8 थ्योरम्स हो जाए, बट ये सारे थ्योरम्स ही बहुत बेसिक है. इस सर्कल चैप्टर में सिर्फ एक या दो थ्योरम ऐसा है जो हमें थोड़ा याद रखना पड़ता है. अच्छा, इस वाले थ्योरम के प्रूफ में अप्रोच ऐसे करना है, अदरवाइज सारे थ्योरम्स जो अब तक हमने डिस्कस किए हैं, वी आर जस्ट टेकिंग द ट्रायंगल्स एंड कॉन्ग्रुएंसी, दैट्स इट. Even if you are not doing it, you are not revising it, if you understood over here, okay, and previously you have given all the tests properly, you are doing all the revisions thoroughly, then without even practicing after this class you will be able to do it directly in the exam. Okay, if previously you have done any time. Let's continue. Next, this theorem is quite different. Okay, the angle subtended by an arc, this one let's do it from the very beginning. ये जो थ्योरम है ये थोड़ा सा हमें याद रखना पड़ेगा that how to approach this theorem. Okay, let me write it. The angle subtended by an arc of a circle at the center. Okay, now only I was telling you how arc create angle at the center. Okay, so there is an arc. I'm just highlighting over here, but without even highlighting, you can just do it directly. So the angle subtended by an arc of a circle. Suppose we are having an arc AB. So angle subtended by an arc of the circle at the center. This angle, this angle. Angle subtended by an arc at the center, okay, is double the angle subtended by it on the remaining part of the circle. ये जो angle है double होगा, okay, 2 times होगा. किसका? Same arc जो remaining part of the circle है, जो बचा हुआ arc हमारे पास दिख रहा है इस purple वाले part को छोड़ के, okay, the remaining part we are having, okay, on that part the same arc is creating an angle. If let me take APB. Okay, so we have to show over here that angle created by an arc at the center is double the angle created by it on the remaining part of the circle. Angle AOB will be double of angle APB. You understand the theorem, right? Anyone who don't like, to whom the theorem is not clear, what the theorem says? Okay, now we have to show it. How we'll be showing here? Do we have any other information? The given part? No, we don't have any other thing. We just know it's a circle. So basically radiuses and all basic things we can take it. Okay. And if any previous theorem, if we can use, we will see, then we'll be using it. So let's prove it. Here we need to use a trick. We will be joining at first OP. Okay, we are doing one construction first, joining O with P. After joining it, if you can see here, we are having two triangles. We are having this triangle. Okay, and joining also like this. OP we are joining and just extending this OP till the point you can call it M. Okay, and extending it, or you can say the mathematical language, producing it, okay, till M. Now, can you see this orange color triangle?
Yes, ma'am.
Okay, in this triangle, can you see we are extending one of the side like this? Yes or no?
Yes, ma'am.
Okay, then by exterior angle theorem, okay, exterior angle property, the exterior angle so form will be equal to sum of opposite to interior angle. Yes or no?
Yes, ma'am.
Okay, so let's write it. We will be writing that here in triangle AOP, in triangle AOP, the exterior angle so form. That means angle AOM is equals to sum of opposite to interior angle. That means angle OAP plus angle APO, exterior angle property. Anyone having any doubts so far? Now
No,
the
ma'am.
same thing we'll be doing for the other triangle, that is PBO. Okay, let's write the same thing. Similarly, we can write in triangle PBO, the exterior angle so form is equals to sum of opposite to interior angle. Okay. One more thing. Okay, here only we must change it. Are you realizing that in this triangle AOP, OP and OA, these two are radius of the same circle?
Yes, ma'am.
Okay,
Yes,
so the
ma'am.
two sides are same in length. Okay, but we know that OP is equals to OA. So the angle opposite to OP and the angle opposite to OA will be equal, yes or no?
Yes, ma'am.
So OAP and APO, these two are equal with each other, right? Which is there in equation
Yes, ma'am.
on the right side. So we can write it. We can write this two angles as, just a second. We can write this two angle at this as this 2 times APO. Why? Because we need only that angle, right? The exterior one and that one. Getting it? Can we write in equation number 1? In equation number 1, AOM is equals to this angle APO plus angle APO. Yes or no? That means 2 times angle APO. Can we write it like this?
Yes, ma'am.
Yes, ma'am.
Okay. Similarly, now we don't have to give that much brief. Directly we can write. Okay. This angle BOM is equals to 2 times of this one, right? Because the other triangle is exactly same, right? BPO, can we write it like this? Right?
Yes, ma'am.
Now we just need to join this 2 and 3. Okay. Adding 2 and 3. When we will add this two equation, we'll be getting AOM plus BOM. That is equals to 2 times angle APO plus 2 times angle BPO. अगर हमने राइट साइड से 2 कॉमन ले लिया तो हमें क्या मिलेगा? APO प्लस BPO. चलो फिगर को देख लेते हैं ध्यान से, फिर बताना मुझे APO प्लस BPO मीन्स व्हाट? APO plus BPO means what? Yes, anyone? ये जो APO एंगल है प्लस BPO एंगल को हम एक साथ ऐड करके क्या लिख सकते हैं? दैट इट इज नथिंग बट एंगल APB. Yes or no?
Yes, ma'am.
Okay, we can write it as a APB. We can write it as a 2 times angle APB. And the other one AOM plus BOM. AOM plus BOM, क्या हम इसे लिख सकते हैं? दैट इट इज नथिंग बट दिस AOB एंगल, AOM प्लस BOM का मतलब है एंगल AOB, हाँ या ना?
Yes, ma'am.
क्या हमें यही प्रूफ करना था? चलो देख लेते हैं. दैट एंगल एट द सेंटर, okay, yes, AOB is 2 times APB. That's what we wanted to prove, right?
Yes, ma'am.
Is it clear? तो ये जो थ्योरम है ये थोड़ा सा ध्यान में रखना कि हम एक्सटीरियर एंगल प्रॉपर्टी यूज करते हैं. ओके, हमारा जो एक्चुअल फिगर, whatever the actual figure we are drawing, we join the P, okay, the point on the circumference with the center, but we extend it. Why? So that we can use exterior angle property of triangle. That exterior angle so form is equals to sum of opposite to interior angle. But यहाँ एक इक्वेशन फ्रेम होगा, यहाँ एक इक्वेशन फ्रेम होगा. आई मीन द इक्वेशन फॉर द लेफ्ट साइड ट्रायंगल एंड द इक्वेशन फॉर द राइट साइड ट्रायंगल, एक्सटीरियर एंगल प्रॉपर्टी यूज करके. बट हमें यहाँ पे केयरफुल रहना पड़ेगा कि ये जो ट्रायंगल हमारा फॉर्म हो रहा है ये आइसोसेलेस ट्रायंगल है, तो दो एंगल आपस में इक्वल होंगे, तो ध्यान रखना. Okay, otherwise if you are just writing the exterior angle property and adding it, then you have to use this isosceles triangle property, then only you will come to the conclusion which we are supposed to prove over here. Got it?
Yes, ma'am.
This is the theorem you need to keep in mind, and the last theorem, this one. Okay, just give me a second, I am proving this theorem. ये जो थ्योरम अभी अभी हमने प्रूफ किया, यहाँ से इस देयर आर टू मोर थ्योरम. ओके, द बाय प्रोडक्ट ऑफ दिस थ्योरम व्हिच वी प्रूव जस्ट नाउ. ये जो हमने थ्योरम यहाँ पे प्रूव किया, इस थ्योरम से और भी दो थ्योरम्स निकल के आते हैं. जैसे वन ऑफ द थ्योरम इज एंगल इन द सेम सेगमेंट आर सेम. एक थ्योरम तो ये है दैट अगर हमारे पास एक सर्कल है, ओके, एंड इस सर्कल में अगर हमने एक कॉर्ड कॉर्ड ड्रॉ किया, कोई भी एक कॉर्ड, सपोज द कॉर्ड इज AB, तो हमारा जो सर्कल है ये दो सेगमेंट में डिवाइड हो गया. ओके, कॉर्ड कॉर्ड हमें सेगमेंट देता है. सेगमेंट मीन्स ये जो कॉर्ड है एंड ये जो आर्क है AB, ये दोनों मिलके सेगमेंट क्रिएट कर रहा है. दिस इज कॉल्ड माइनर सेगमेंट and the upper one is called major segment. Do you know that?
Yes, ma'am.
Okay, तो जब भी हम सर्कल में एक कॉर्ड ड्रॉ करते हैं तो जो एरिया हमें मिलता है, आई एम टॉकिंग अबाउट दिस एरिया, दिस इज कॉल्ड सेगमेंट. हमें यहाँ पे दो सेगमेंट्स मिले, द अपर वन एंड द लोअर वन, एंड द लोअर वन इज स्मॉलर कॉल्ड माइनर सेगमेंट, अपर वन इज बिगर कॉल्ड मेजर सेगमेंट. तो एक थ्योरम यहाँ से ये निकल के आता है जो हमने ये रेड कलर वाला रेक्टेंगुलर बॉक्स में अभी अभी जो थ्योरम प्रूव किया है, वहां से एक थ्योरम निकल के आता है दैट एंगल इन द सेम सेगमेंट आर सेम. अगर हमारे पास अगर अगर दो पॉइंट्स है, लेट्स से P एंड Q, ओके, पॉइंट पी पे ए बी chord is creating an angle. Chord AB is creating angle at point P like this, and the same chord is creating angle at Q. ओके, तो ये दोनों एंगल P एंड एंगल Q सेम सेगमेंट में क्रिएट हो रहा है. यस और नो? यस और नो? यस और नो? This
Yes,
angle P
ma'am.
and angle Q, these two we are having in the same segment. Both are in the major segment, created by same arc or same chord. अगर ऐसा सिचुएशन है, ऐसा सिनेरियो है, तब हम बोलते हैं दिस टू एंगल आर इक्वल विथ ईच अदर. क्यों? क्योंकि अभी अभी हमने बोला कि अगर हमारे पास सिर्फ एक पॉइंट P है, ओके, एंड देयर इज अ chord, दिस chord क्रिएटिंग एंगल एट P. ये जो P एंगल होगा, इसका सेंटर के साथ, सेंटर वाले एंगल के साथ एक रिलेशन है. ओके, दैट सेंटर एंगल मस्ट बी डबल ऑफ P, right? Right, this is what we proved just now, that angle created by an arc or by a chord, okay, at the center is double of the angle created by it on the remaining part of the circle. So can we write from here that angle AOB is double of APB? Can we write it?
Yes, ma'am.
We can write it. Okay, and what about the case if suppose one more angle is getting created like this? Q, तो भी ये सेंटर वाला वैलिड होगा जो थ्योरम हमने प्रूव किया. हम बोल सकते हैं दैट ये जो एंगल ए क्यू बी है, ओके, जस्ट अ सेकेंड, आई मीन द सेंटर एंगल AOB, that will be double of AQB. Yes or no?
Yes, ma'am.
और इक्वेशन 1 एंड इक्वेशन 2 को अगर हमने कंपेयर किया, बिकॉज दिस इज AOB, दिस इज आल्सो AOB, वी कैन कंपेयर देम. आर वी गेटिंग APB एंड AQB आर सेम? Yes or no?
Yes, ma'am.
This is the theorem, angle in the same segment are same. अगर कभी भी एग्जाम में ये थ्योरम प्रूव करने को बोल दिया जाए, दैट प्रूव दैट एंगल इन द सेम सेगमेंट आर सेम, ओके, तो हम डायरेक्टली ये दो स्टेप का, यू जस्ट सी, चेक इट, क्या ये क्वेश्चन 5 मार्क्स का है? अगर 5 मार्क्स का है तो यहाँ तक हमें प्रूव करके और उसके बाद हमें ये दिखाना पड़ेगा. अगर 2 मार्क्स का क्वेश्चन है, देन डायरेक्टली दिस ओनली 2 स्टेप्स यू विल बी शोइंग. गेटिंग इट? ओके, सो एंगल इन अ सेम सेगमेंट आर सेम. दो एंगल जो सरकमफेरेंस पे बन रहे हैं, सेम कॉर्ड बना रहा है या फिर सेम आर्क बना रहा है, दोनों ही एंगल इज जस्ट क्रिएटेड बाय सेम आर्क, or maybe we can call same chord, then this two angle will be same. Okay, next one more theorem is there, that angle in a semicircle are right angle. अगर हमारे पास एक सेमी सर्कल है, एक डायमीटर है ऐसा, ओके, और अगर हमारे सेमी सर्कल में एंगल क्रिएट हो रहा है, सेमी सर्कल में एंगल क्रिएट हो रहा है, दैट मीन्स ऑन द सर्कमफेरेंस the angle is getting created, then this will be 90 degree. Why it will be 90 degree? क्योंकि अभी अभी हमने सीखा है कि जो सेंटर पे एंगल क्रिएट होता है, अगर हमारे पास एक आर्क है, अगर हमारे पास एक सर्कल है, ओके, लेट्स स्टार्ट फ्रॉम द वेरी बिगिनिंग. अगर हमारे पास एक सर्कल है, उस सर्कल में एक कोई भी एक आर्क है या फिर कॉर्ड है, देन एंगल क्रिएटेड बाय इट एट द सेंटर will be double of the angle created by it on the remaining part of the circle. तो जैसे ही हमने देखा कि एक ये जो कॉर्ड है, ओके, AB is a chord and AB is diameter as well. ओके, diameter is the biggest chord. डायमीटर को कॉर्ड भी हम बोलते हैं क्योंकि कॉर्ड का डेफिनेशन होता है सर्कल के ऊपर किसी भी दो पॉइंट को हम ज्वाइन करें तो हमें एक लाइन सेगमेंट मिलेगा, उस लाइन सेगमेंट का नेम कॉर्ड है. ऐसे ही डायमीटर हमें मिलता है सर्कल के ऊपर दो पॉइंट को ज्वाइन करके। बट ये जो कॉर्ड है ये स्पेशल कॉर्ड है, ये सेंटर से पास होने वाला कॉर्ड है जिसे डायमीटर भी कहते हैं। गेटिंग इट?
Yes, ma'am.
तो अगर कभी ऐसा क्वेश्चन आ जाए दैट डायमीटर इज अ कॉर्ड, ऑफ कोर्स इट इज अ कॉर्ड। Okay, diameter is a chord. It's a special chord passing through the center of the circle, and diameter is the biggest chord. Okay, you can see as well in circle that this is the maximum length you can draw, and after that whatever chord you will try drawing, that will be smaller than this one. Okay, so yeah, let's continue. So angle in a semicircle is right angle. जैसे ही हमने देखा कि एक कॉर्ड एंगल क्रिएट कर रहा है और इस बार ये कॉर्ड स्पेशल कॉर्ड है दैट इज डायमीटर, तो हमने देख लिया कि ये ऑलरेडी 180 डिग्री क्रिएट कर रहा है सेंटर के ऊपर, हाँ या ना? राइट?
Yes, ma'am.
तो जो सरकमफेरेंस पे एंगल क्रिएट होगा वो हाफ होगा, इसका सेंटर वाले एंगल के हाफ होता है। राइट? राइट? डू यू नो दैट सेंटर एंगल इज डबल? तो अगर सेंटर वाला 180 है, देन हियर वी मस्ट टेक 90, तभी तो ये डबल होगा, हाँ या ना? आ रहा है समझ में? नो, आई एम सेइंग दैट वी नोटिस दैट एंगल क्रिएटेड, this AOB angle is 180, and we know the red color, the highlighted part, the rectangular box. So from there, are you getting that APB is nothing but AOB by 2? Yes or no?
Yes, ma'am.
That means 180 by 2, that means 90 डिग्री। तो अगर सेंटर पे 180 डिग्री क्रिएट हो रहा है तो ऑफ कोर्स सरकमफेरेंस पे 90 डिग्री क्रिएट होगा। इज इट क्लियर टू ऑल ऑफ यू?
Yes, ma'am.
ओके, तो इन केस अगर ये वाला थ्योरम आ जाए दैट प्रूव दैट एंगल इन अ सेमी सर्कल इज राइट एंगल, तो बस ये दो स्टेप है दैट वी नो दैट द डायमीटर इज क्रिएटिंग अ लीनियर पेयर 180 डिग्री एट द सेंटर। Okay, a straight line angle, better to call it a straight line angle. Okay, 180 degree at the center, and we know that AOB is equals to 2 times APB. Then from there we are getting APB as a 90 degree. याद रखना ये थ्योरम, जो हमने ये थ्योरम डिस्कस किया है, that angle created by an arc at the center is double the angle created by it on the remaining part of the circle. तो अगर क्वेश्चन में इन केस यहाँ लिखा है 14 डिग्री, then this will be of course 2 into 14, that means 28. बट इन केस हमारा क्वेश्चन अगर ऐसे दिया हुआ है दैट एंगल ऑन द सर्कमफेरेंस वी आर सपोज टू फाइंड, and the center's angle is given as a, let's call it 100 degree, then this angle on the circumference will be half of that. Do you know that?
Yes, ma'am.
Yes, ma'am.
Okay, please keep it in mind. Now the last theorem which I wanted to discuss today is this one, but it will take few minutes to explain you everything in detail. Okay, so I'll be explaining it in the next class. If a line segment joining 2 points obtain equal angle at two other point lying on the same side. Okay, first I'll be explaining the theorem, and then we can discuss the proof. This is the last theorem which you need to know. After that, one cyclic quadrilateral we are having, where proof you don't need to know, just the theorem. Okay, so this is the last theorem. I'll be taking it in the next class. Okay, till the next class, please go through all the theorems which we have covered over here, and let me know